Welcome to Study Loop.
For this problem, we're going to be using bitwise operations on bit strings that are showing combinations of letters. Now, I've already I put together a grid. I think just make it easier to see on the screen here. And across the top of the grid, I've put all the 26 letters of the alphabet. Z, I was one column short, so Z will be just off of the right edge of the grid here. Now, let's take a look at what our sets are. We have set A. And set A is made up of A, B, C, D, and E. So if I'm going to make a string out of these, I'm going to have a 1 in each of those positions because that's where I have elements. And everywhere else is going to be a 0 because there are no other letters in this set. So there's set A. How about set B? Well, set B is made up of letters B, C, and D, G, P, T, and V. So those elements have 1s. And since those are the only elements in set B, to put together our bit string here, we're going to put 0s everywhere else. Okay, 2 more. We've got C. C has elements C and E, I, O, U. We have I, we have O, we have U, and then X, Y, Z. Okay? And since those are the only elements in set C, we're going to put 0s everywhere else. Okay, and let's look at D. Set D has elements D, E, H, I. So D, E, H, I, N, O, and T, U, X, and Y. And again, just like with the other sets, anywhere that we did not put a 1, that means that we don't have that element in this set. So we're going to put 0s. Okay. Now, again, you don't need to use graph paper to do this, but I find it makes it a little bit easier to see, keeping everything straight. So those are our 4 sets. Now we have 4 things we're going to find. So first, I'm going to switch colors so it stands out a little bit. I want to find the union of sets A and B. So that means I'm looking for any element that is in either A or B. So if I look up here, I'm comparing these 2 rows. So that means I have A, B, C, D, and E. I also have G, P, T, and V. So all of those spots have 1 in either A or B. The other ones just have 0s. So they're going to put 0s in all of those spots all the way across. This would be the string that shows what those elements are. And again, if you want to see the letters, you can look at the top and see that that first 1 corresponds to A, the second one to B, and so on. But that string would be the bitwise operation that we did here. Okay, next, we want to find an intersection. What about the intersection of A and B? Well, again, we're going to be looking at those first 2, but this time we want the intersection. Where do both of them have a 1? Well, they both have a 1 in B, C, and D. And those are the only elements where that is true. So all of the other 23 letters of the alphabet are going to get a 0 in our string, all the way across to Z. Okay, our next one. Well, this is in 2 parts because we have the intersection of 2 unions. So what I'm going to do for this one is I'm going to break this up. Okay, and I'll go back to blue for this one. So the first piece is the union of sets A and D, and then the intersection of, let me give myself a little bit of a break here. So the union of A and D, and then the union of B and C. And then once I have those 2, I'll take the intersection of those 2. I'll take the intersection of the 2 unions. Okay, so that's what I'll be doing here. So first, A and D. So I am looking at the first and the last set of those red lines. Okay, anywhere where either one has a 1, Well, A has a 1 in A, B, C, D, and E, so we're going to put 1s there. Now, D also has a 1 in H and I, N, O, T, U, X, and Y. So everywhere else will be zeros. Okay. Now, the second piece of that, I'm not looking at A and D anymore, so I'm going to erase those arrows. Instead, I'm looking at B and C, so these two middle ones, where either one of those has a 1, that will be in the union. So that is going to be B, C, D, E, G, I. We move all the way over to O and P, T, U, V, X, Y, Z. Okay, so that's got quite a few elements in it. So everywhere else is going to have a 0. Okay, now that that's done, we're ready to put them together, and this will complete this portion of the question. So now, looking just at these two, what is their intersection? Where do they both have a 1? So that will be B, C, D, and E. They both have a 1 in I, O, T, U, X, and Y. Everywhere else, either they're both zeros or only one of them has a 1. So we're going to fill in the whole rest of the string with zeros. Okay, last piece. Okay, change color one more time. Now we're going to be finding the union of A and B and C and D. So any one of these 4 rows, if there's a 1 anywhere, it's going to have a 1 in this because I'm putting all of them together. So that's going to be A, B, C, D, E, not F, G, H, I. Now there's a string here. None of them had J, K, L, or M. But we have an element N, O, and P. They get 1s. Now again, we have another stretch. Nobody had Q, R, or S. But we need to include T, U, and V, not W, X, Y, and Z. So combining all of those together in a union, that's what that would look like. So this is how you can use bit strings, to use bitwise operations to do these intersections and unions of sets.